Let's talk about it. So 11.6, here's question number 1. They want me to solve the system. So a system means more than one equation at the same time. Solve, so we got 2 equations right there, 2 equations. But these are not lines. That's what's different. You've solved 2 equations before. Like, let me show you. Like last night's homework, you probably had things like from 11.1, right? 2x plus 3y is 7, and x minus 4y is 12, or whatever. And you solved ones like that, huh? Using, maybe you did it on the calculator, or maybe you did it with the addition method or the substitution method, whatever. Any of those is fine. But those are both lines, right? How do I know those equations, if I graphed them, would both be lines? How do I know? What is it about an equation that makes it become a line when graphed? Yeah, it's x and y are just the first power, so you can get y alone and get mx plus b. Yeah, if x and y are just first power, added and subtracted first power, those are going to be lines, aren't they? We call those linear equations because the graphs are lines. So if you graphed them, it'd just be, on the graph's going to be one line like this and another line like that, and you find that one intersection point. Now, you probably didn't graph them. I'm assuming you didn't graph them. But that's really what's happening behind the scenes. When you did the addition method or the substitution or the calculator, the answer you got, like maybe 1, 3, x, y, that's really the point of intersection between those 2 lines. So now what we're doing is we're not going to graph, but we're solving these 2 things. They're not lines. So there's going to be more answers. In fact, what are they? Let's start with this second equation. We don't have to graph, not at all required. But it might give us some insight as we begin the problem. What is that second? Let's start with, we'll go back to the first, but let's start with the second. I'm hoping maybe some of you recognize that kind of equation. It's one of the ones we just did on the test we said. That's an ellipse, yeah, because it's got x squared and y squared, and it's added, right? They have the positive relation. They make the egg shape. If that was minus in the middle, it'd be a hyperbola. Branches that turn away either up, down, and right, left, huh? So that's an ellipse. So if you're thinking about a graph, you have some kind of ellipse. Okay, that's that one. Now, what's this graph? That's not a line, because you might think, well, x and y first power, that's a line. Well, they're times, though. If it was x plus y equal 3, then that would be a line, But if they're multiplied by each other, it's actually not a line. Well, what is it? It's not really something you might feel like you've seen. You actually have, it's just in a different look. If you get y alone there, what would y alone equal in that equation?
3 over x.
3 over x. Does that look a little more familiar now? Let me do one more rewrite. 3 times 1 over x, the same thing as 3 over x. That's like y equals 1 over x with a 3 in front. Remember what 1 over x? We've done that for a while. That's the one that has the 2 diagonal branches. And the 3 in the front makes it go up and down faster? Yeah, so that's what that is. That's actually 2 diagonal branches. So if I put 2 diagonal branches, again, none of this is required. If you put 2 diagonal branches like that, you're going to have 1, 2, 3, 4 points of intersection. Now, maybe the branches are further out and they don't even touch the ellipse and we have no intersection. They don't usually do that. But yeah, in general, that's possible, of course. But probably they're going to have the things hitting each other. They want us to have answers to find. And so we're expecting probably there's going to be 4 answers. They could be it barely nicks it on each side. There's only 2 answers, but again, that's rare. Could be no answers, could be 2 answers. Probably there's 4. Probably, and there will be. There's 4 answers. So see how I'm thinking about the graphs, I'm knowing what to expect. Should be 4 answers. All right, so let's get down to actually finding those 4 answers now. So let me rewrite it here with a little more room. X times y is 3, and 3x squared plus y squared is 12. 3x squared plus y squared is 12. Yeah. Okay. So what do you think? We got to solve 2 equations at the same time. It's a little more complex than just lines.
Can you do a substitution?
Substitution. Yeah, pretty much that's what we're going to do for the next hour. Is we're just going to plug the easier equation into the harder. So let me just write that out for you. Plug easier into harder. Plug the easier equation into the harder equation. So which one's the easier equation? A top one, huh? So you can get x alone or y alone, doesn't really matter which. I'm going to, I'll just get x alone. So x is 3 over y, and then I'll grab that, and I'll plug that in right there for x in the other equation. So start with the easy one, get x alone or y alone, whatever, plug into the other one. All right, so what do we get? 3 times 3 over y squared plus y squared is 12. Good to there. So now it's just a big mess of algebra. It's a lot. It's all stuff you know. It's just a lot of it. Just a lot of algebra. These are long. There's 8 of these. Each of these, I would think in your homework, half an hour. 20 minutes minimum. It'll take us 15, and I'm guiding you straight on through with no hiccups. So, I think half an hour, this would be a 4-hour homework assignment, really, to do a thorough job on it. So, all right, so how do we get it here? What do you do with that square?
Over 9 of y squared.
Yeah, 9 over y squared. That makes sense there? I just squared the 3 and squared the y. And then how do I do the like the whole number interacting with the fraction there? Yeah, put it over 1. Exactly. And then it's top times top and bottom times bottom. 3 times 9, 27. 1 times y squared, y squared. Good job. That good so far? Now, kind of get to here, we can sort of pause for a second and think, okay, what should I do with this thing? It's kind of weird looking. I think when you have fractions, it's always a good plan just to get rid of those fractions, So what's going to get rid of all those fractions? Yeah, multiply through by the y squared. Multiply by the y squared. Y squared, y squared, y squared. Cancels out right there. So I get 27. And what's y squared times y squared in the middle there? Y to the 4th, right? Powers that, right? And this is 12y squared. We good to there? Got rid of the fraction, so that's nice. Now what?
Bring y squared to the other side.
Yeah. So let me write up here for you a general game plan. Generally, when you have y squared or like y to the 4th, generally what you want to do, the usual typical, is to get a 0 on one side and try to factor the other side, with the parentheses and stuff. Or the other thing you could do is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me at the same time, though, give you another thing that can happen that's even easier. If you have y squared and no y to the 1st. So if you happen to have, this will come up often, when you have y squared and you don't have like a regular y to the 1st, those are actually easier. You don't have to do all the 0 factor stuff. You just get the y squared alone, and you do the root and the plus or minus, or just get y squared alone and root it. So those are kind of the 2 big game plans that we're going to follow in what we're doing today. We're just going to keep doing those 2 things. So let's go back to it. So now, let me create a little room here. Bring this thing over. So we have 27 plus y to the 4th is 12y squared. Okay, so when I see like y to the 4th, what should be my first game plan? Get a 0. Yeah, bring it over on the same side to get a 0, huh? That's what I'm saying. First thing is when you see that, get a 0. So yeah, totally. Just bring this guy, just jump him over. And put those in order, huh? From highest power to lowest. So that'd be y to the 4th minus 12y squared plus 27 is 0. Like that? That good? And now, can you factor that? Let me give you a chance. Give you just a second to factor that. like with 2 parentheses. That's what you remember about factoring. So yeah, so we're looking for 2 things here and 2 things here. So we want, remember how it works? The front one times the front one is y to the 4th. What times what? Yeah, y squared. Y squared in the front, so I'll make y to the 4th. Okay, and then how about the back? What multiplies to be 27 at the back? What times what's 27? 3 and 9. And how can they add? Remember the middle is adding. Remember that in factoring? How could they add to be negative 12? Both negative, huh? Both negative, yeah. Okay, so now where do we go from there?
Each one is equal to 0.
Yeah, each one equals 0. Remember that? Because if 2 things are timesing to equal 0, either one could be 0, couldn't it? So the first one is 0. Or the second one could be 0. Okay, so the first one is 0 or the second one is 0. And then how do you solve each of those? Just get it alone and root it, huh? Yeah, just jump this 3 over. Y squared is 3. And root it. Roof on the house. Up and down left. Don't forget the plus or minus. That'll be real important today in what we're doing. So y is plus or minus root of 3. And then on the other side, jump the minus 9 over. Becomes a positive 9. And roof on the house, up and down the ladder, plus or minus regular 3. So we got 4 answers, just like we were expecting. Plus or minus root 3 and plus or minus regular 3. Now those are all the y's. We got to take those now and plug in all 4 of them one at a time. These are long. And get an x that goes with each of them. Because we got to get x, y answers in the end. They want x and y. So let's take it to a fresh screen. If you're okay with that, I'll take it here. And I'll go, okay, so y equals minus root 3. And then y equals plus root 3. And y equals minus regular 3. And y equals plus regular 3. Got to plug all those in. Now, what's going to be the easiest place to plug in? Well, now think with me. Yeah, because we're looking at the original 2 equations, and the first one's way easier than the second one, huh? But there's even an easier place than that. Definitely, I mean, the first one would be good. If you did the first one, it's going to be pretty easy. But there's even, think about what, I've got y, got 4 answers for y. So what I want is x. So if you want x, this is what we're going to do every time on these problems. So just think, okay, what do I want? I want x. So go somewhere where x is already alone. Where do you see up there that x is already alone?
Where we solved for x, like x equals 3 over y.
Yeah, right there. That'll always be how we wrap these up. There'll always be a place where the other letter is already, in fact, it'll be what we used to plug in the beginning. Just reuse that. That'll be even quicker. It's not a big deal here, but sometimes it will be more important. So yeah, so use that. So x is 3 over y. So for all these, I'm going to plug in x is 3 over y. So now plug in the y's and get the x's that go with each of those, right? These are 4 separate deals, aren't they? So 3 over negative root 3. Just plug that in, plug that in, plug that in, and plug that in. Now, what do we do when we got a root on the bottom? Yeah, multiply top and bottom, by root 3. like that. And you get 3 root 3 over negative 3. Everybody okay with that bottom, how I got negative 3? Because 2 root 3's make a plane 3. Remember that? Remember 2 are the same thing in roots? Send 1 out. Root 3 is root 9, which is plane 3. And then you cancel these 3's, huh? So x in the end is just negative root 3. You keep the negative sign from the bottom and the root 3 from the top, and they get together, negative root 3.
So you didn't want a root in the bottom, is that what you're saying?
Yeah, we couldn't leave that root in the bottom. So I multiplied top and bottom by root 3. So everybody good with that? Remember how the root 3 in the bottom make plane 3? The 2 roots in the bottom make a plane 3. And so there we go. So what is that answer then? That's the x negative root 3 going with the y from which he came. Negative root 3. There it is. That's x, y. Does that make sense? So you want it. So now the middle one, the second one, I mean, is going to do the same thing. Do you see how it's going to be exactly the same? It's just positive instead of negative. I mean, you can go through the steps if you want, but the answer is going to be the same. It's just going to be positive instead of negative. 3 over root 3. Can't leave a root in the bottom. Right? Don't leave a root in the bottom. So multiply top and bottom by root 3. And we get 3 root 3 over plane 3. The bottom, root 3, plane 3. And then the 3's cancel. See, it's just positive root 3. So that gives us the answer. Root 3. Root 3 at x root 3, going with y root 3, xy. Good with all that. And then the next one is going to be even easier. X equals 3 over y. Y is negative 3. And that's x is negative 1. And so that answer is negative 1, comma negative 3. Finally, over here, x is 3 over 3, x is 1. Answer is 1, 3. So there's the answer. What do they want from us as the answer? They want all of these, and they want commas in between. So I'll go comma, comma, comma. There we go. It's time consuming just to type in the answer. So I'm saying these are about a half an hour each, or at least 20 minutes, I would think.
And then you forget a comma.
Oh, yeah, then you figure one little thing and the crazy math Excel hassles you. Is that good? You doing okay on that? That makes sense? No questions? So big old mess, huh? Couple steps. So you grab this and you plug it in for y. Right there, right? Plug that in for y. And so then you should get 7x squared plus, and then the y is x plus 3 squared, yeah, is 9. And so then you got to square that whole thing out, huh? And whenever you have a 2 on parentheses, you got to write 2 of them, don't you? Yeah. So then this x, you got to FOIL this. And so you'll get 7x squared plus, and then FOILing all that out, x squared plus 3x plus 9 equals 9. Come on. All right, and so we get to there. So now, did you gather like terms from there?
Mm-hmm.
So gather in the like terms. 7x squared and x squared. 8x squared. 3x and 3x. 6x. And yeah, with these 9s, remember what we're always supposed to do. What's the game plan? Get a 0, huh? So whenever we have x squared or y squared, we want to get a 0. Yeah, so if you subtract 9, subtract 9, you're going to get equals 0. Like that. We good?
Yeah.
So we're going to get 0. So now, can you factor it? So we got a 0. So the game plan when you have x squared or y squared is to get a 0, which we've got, and factor. Now how does that factor? That's actually easier. That's where you just take out what's in common and do 1 parenthesis, not 2. Remember that difference? Right? You should always try to take out what's in common first. What's in common to those two? 2 and x, huh? 2x? Yeah. So take out 2x. My pen, I gotta update the thing. So 2 and x. Take it out. And what does it leave? 2x times what would go back to 8x squared? 4x. Right? 2x times 4x would go back to 8x squared. Remember, out front numbers multiply, powers add. And then 2x times 3 would go back to 6x. Okay, got it factored. So that's the general game plan when you got x squared or y squared or 4th power. Get a 0 factor. What do you do now? What's the next step from here?
2x equals 0.
Yeah, because if two things times to be 0, either one could be 0, huh? So this could mean like the first one is 0. So 2x alone could be 0, or the 4x plus 3 can be 0. Is that good? Either one can be 0. And then just solve for x in both cases. So that would be divide by 2. And these cancel. 0 over 2. 0. And over here, I'm gonna jump the 3 to the other side, or just subtract 3. Same thing. So 4x is negative 3. Sorry, my pen's being funny. Negative 3, and then last step, divide by the 4, huh? Boom. X is 0 or negative 3/4. So we got 2 answers for x, but we have to see if they're right. I know, that's not right. We have to find the y's that go with them. I'm used to checking things. We're not checking. We're just finding the y's that go with them. Right? So for each of those x's, there's going to be a y that goes with it. So, okay, so I'll bring them up here. And I'll take the first one. So x is 0. And then the second one. X is negative 3/4. Okay, so take those two answers and plug them in. What's going to be the easiest place to plug in?
Y equals x plus 2.
Yeah, you're going to want to go where what we want. We have x. What do we want? We want y. So is there somewhere where y is already alone? That top equation. Yeah. That's going to be the easiest thing with the least amount of work. Does that make sense? Y equals x plus 3. Y equals x plus 3. So, all right. So we have y equals x plus 3. Plug that in for both equations. All right. So I'm going to plug in the 0 right there for x, and plug in the minus 3/4 right there for x. So what do we get then? We get y equals 0 plus 3. And so that means y is 3. And then the other one, so the other one's going to be y equals, yeah, you could use a decimal if you want. Will they take a decimal answer? I think they will. You could just make that decimal, or I'll just do fraction, whatever.
They like the fractions. I know that's what they ask for when you get it wrong.
Do they? Okay. I'll just do the fraction. Like that. So I'm doing minus 3/4 plus 3. How do we add those when you got a fraction in a whole number? What do?
You split the 3, multiply 1, and multiply by the base of the base.
Put the 3 over 1. Whoops. And multiply, not this one, but the other one, top and bottom, by 4.
Or $3 minus 75 cents.
Yeah. So minus 3/4 plus 12/4, and we get, what is that going to be? 9/4. Well, my iPad is painfully slow. Something's wrong with it. Technology. So 9, it won't keep up with my pen. 9/4. Looks like it's super slow. All right, so there we go. We got the answers. Do you know what they are? So what are the final answers then? It is, so the x0 led to y3. So that's the answer, 0, 3, comma. And then here, x negative 3/4 led to y 9/4. That's the answer, negative 3/4, comma, 9/4. So there's the two answers with commas on that. Is that good? Questions on that one? Like you can do that with the greatest of ease? Or lots of pain? It's not too bad, right? It's just tedious. All right. Okay, so we always start with the easier equation, which is the bottom one in this case, and do what's easiest to be get y alone. So I'm going to grab that 3x and jump it to the other side. So that will be y equals 7 minus 3x. And I'll take that now.
I make it negative 3x plus 7.
Yeah, you could also make it negative 3x. Does everybody know that's exactly the same? Either way is totally good. Remember, order never matters. All that matters is the sign in the front. So see how this has nothing in front of the 7, which means plus, same. Negative in front of 3x, same. Yeah, so either way is totally good. So now let's take that, and that's from the second equation, so I'll plug that into the first. So bring it up here, and I'm going to plug in for what? For y and for y. Everywhere I have y, because that's what y is. Why is that? Okay, so what does that give me? That gives me 9x squared minus x times y. What is y? 7 minus 3x plus y again. 7 minus 3x squared is 35. Good to there? And now we just start dealing with a mess, huh? So now it's 9x squared. Distribute. Be careful with your signs and all that little stuff. Minus 7x plus 3x squared. This, we've got to write two of these, don't we? Whenever there's a 2 on a parenthesis, you got to write two of them. Like that. Okay. So now, where are we at? Minus 7x plus 3x squared. Then FOIL this. This is going to be 49 minus 21x minus 21x plus 9x squared is 35. And now gather like stuff. So be careful, underline, circle, cross out, whatever. 9x squared, and 3, 18 and 3, 21x squared. And then minus 7x minus 42 is minus 49x plus 49 is 35. Good to there? Okay, so when we see the x squared, what's supposed to be our general plan? Whenever you see x squared or y squared or higher powers, get a 0, huh? So first thing is get a 0, so that means whatever's on the right side, just do the opposite. So I will subtract 35 from both sides. And so that will give me 21x squared plus 49x plus, what is that, 14 equals 0. Good, so you get a 0, and then you try to factor. Now, I don't know if you noticed, what can we do to factor that guy? What do they always look first when you're factoring? Always ask what's in common to all the, what number? 7, huh? The 7 goes into all those, doesn't it? So we take out the 7, and then that's, whenever you do what's in common, that's just the one big parenthesis, not the 2. The 2 will come later. So we're taking out what's in common, it's just one big parenthesis, it's common to all. That'd be 3x squared minus 7x plus 2. That good to there?
You're good at factoring. I just threw it in the quad.
Yeah, so you could throw that in the quad, or you could factor further. If you're good at factoring, that's quicker. Boom, boom, you're done. But you can do, but I've noticed over the years, most students prefer to just do the quad if you're a little rusty on factoring. So I'll take it to a new screen. We good to there so far? So we have 7, what was it? 3x squared minus 7x plus 2. And you know, really, that 7 in the front, you could just divide by 7 on both sides and get it out of there. You know what I mean? Gone. And so
7 cannot equal 0.
3x squared minus 7x plus 2. 7 cannot equal 0? That's kind of a funny statement.
Well,
I certainly agree with it.
Where you would have 2x equals 0 and divide by 2, you can't do that with 7.
Oh, right. So what is 0 over 7? 0? So yeah, so we just get to there, right? Just get rid of that 7 in the front. Just divide it out of there. Okay, now this does factor further. If you're a good factorer, you could save some time. But I'll just do the quad. I know most people like the quad. That's totally fine. So I'll just identify this is A. This is B is the negative 7, huh? A is the 3. C is the 2. Don't forget the sign in front of the B there, the negative 7. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, so negative b, watch the signs really carefully. So it's negative b.
So negative is positive.
Yeah, negative 7, huh? It's going to end up being positive. We good because b is negative 7, notice? The formula says it's negative whatever b is. So it's negative 7. It's going to be positive 7, huh? Everybody good with that? Plus or minus square root of b squared. So minus 7 squared minus 4 times a, 3, and c, 2, all over 2a. Like that. All right. And so x will equal, so the two negatives there is positive. So regular 7 plus or minus the square root, what's that, 49 minus 48.
3 times 2
Oh, 24.
is
24. All right. And so that's going to be
25.
7 plus or minus.
7 plus 5.
Funny, the pen just stops working all of a sudden. 7 plus or minus the square root of 25 all over 6. Yeah, that's nice, huh? And so that's 7. Square root of 25?
5.
It's just 5. And so those two, so now we just separate to get those two answers. Remember how that works? So it'll be 7 plus 5 over 6, or 7 minus 5 over 6. So that's what? 12/6 or 2/6?
2 or 1/3.
Yeah, I'm running out of room here. So x is 2 or 1/3,
No, each
right? Because
section
12/6
will be 0.
is the 2, 2/6 is the 1/3. So I got my 2x answers. Did you get to that okay? That making sense? And now you just got to plug those in. And what's going to be the easiest place to plug in?
Y equals
Then we
y.
solve.
Somewhere where y's alone, huh? Because I have x now, got my 2x answers. So the easiest thing would be to go somewhere where y, which is what I want. I've got x, I need y. Where's y already alone? Yeah, there it is. It's always that thing we use to plug in. Have you noticed that always works that way? So 7 minus 3x or negative 3x plus 7.
Then in the plug, you don't have to set it equal to 0.
Right, we skip all that. Well, no, we do set equals 0. Yeah, we had it equals 0 before I did the quad.
Well, no, like.
Oh, not later. No, it just boom, there's your answers, yeah. All right, so we have our two answers. X is 2 and x is 1/3. Each of those now will go to a y answer. What was y? Y is 7 minus 3x. So you grab that 2 and plug it in for x. 7 minus 3 times 2. 7 minus 6. Y is 1. So that's the answer. X is 2, y is 1. And then the other side. Same same formula to plug into. 7 minus 3x, grab that 1/3, plug it in for x. 7 minus 3 times 1/3. 3 times 1/3? Yeah, it's nice, huh? Y is 6. So the answers are 1/3 for x, 6 for y. So there we are. There's those two answers. Is that good? Long, tedious. Make one little negative sign slip up and it's all messed up, huh? Are we good there? I don't know how many more. What was that, number 4? I forgot now. We go so long. 4. Yeah, that was number 4. three screens later. That was the answers to number 4. So it wants both answers with a comma in between. Just like that. Either order. Hey, why did we get 2 answers there? Let's look back at the original question and see if we would have expected those 2 answers.
Y squared x squared.
Yeah, this first equation, graphically, like what kind of graph is happening behind the scenes there? This first equation, what kind of equation is that? It's got x squared and y squared. Are they added or subtracted? Added. See how it's plus y? I don't care about that xy term in the middle. That doesn't matter. It's this plus y squared, and the x squared is also positive. So that's what kind of? That's an or an eclipse too. It's an ellipse. It's an egg shape. The moon goes between it. Yeah. All right. So, and what's the second equation? What's this? That's a straight line. That's linear. So what does a line in an egg shape do? Usually hitting 2 points. Now, it could nick it in only 1 point or not hit it at all 0, but usually 2 answers. That's why we got 2 answers. That's what we really found, is where the egg shape and the line hit. These two answers are the 2 points on the, if we were to take the time to graph, which we don't have time for that, but to graph them both. But you have know-how. You know how to graph lines. You know how to graph ellipses. If we graphed it all, we'd find these are the 2 intersections between the ellipse and the line. You guys have a lot of algebra skills at this point.
Apparently not.
All right, so is that good? So notice what's different. Let me write a note for you. In problems 5 through 8, x squared and y squared for both equations. What's different? In problems 1 through 4, one equation was x to the first and y to the first. So that's the difference. In problems 1 through 4, you always had one of the equations just being x to the first, y to the first, right? That was the easier one. We'd always start with that one, plug into the other one. But in 5 through 8, 5, 6, 7, and 8, they're both squared. See how number 6, there's no easier equation, is there? But this won't be harder. This won't. It's just it's going to handle it a little bit differently. In fact, it might be easier. In some ways, it's easier. But it's different. Everybody see the difference there? We don't have an easier one that we plug into the other one. Really, that means you can plug either one into the other one. Because they're equal. They're equal level equations, aren't they? They're both just x squared, y squared. Okay, so what are we going to do? Generally, the same thing. You want to get, but it's squared this time, not x to the first power, not y to the first power. So you want to get x squared alone, or y squared alone, and plug into the other equation. It's the same general plan, plug into the other equation. This one's, I picked the hardest one. Number 6 is harder than 5, 7, and 8. Because notice there's not a plain x squared anywhere. Do you know what I mean? Let me change it. Let me see if you're tracking with me. If that wasn't there and there was just like a regular x squared, I would get that alone, huh? And plug that into the top equation. Or if there was just a plain y squared, I would get that one alone, right? It's easy to get something alone that doesn't have a number in front of it, right? That's easier. So this one's hard. This is the hardest one because it doesn't have that. Everybody's got numbers in front of them. So which one am I going to get alone on this one? What would be the easiest way to go? Well, I think it would be hard to deal with the top. If I did anything with the top equation, I'm going to have fractions. Yeah. Do you see that? If I got y squared alone, I'd have fractions. Or I don't want to do that. Take the second equation. The first thing I would do is just divide through by 4. See what I'm thinking about there? And then I'll get rid of those 4s. See my thought? I'm wanting to make something easy. I'm wanting to get x squared. Or yeah, you don't have, if you want to just get x squared alone, how about that? Maybe I'm being confusing. Just get x squared alone in that second equation. How about that? Just grab that 4y squared, jump it to the other side, and we'll get 4x squared is 74 minus 4y squared.
No, divide.
Would it matter if you were looking for y instead of x? Like for that one, instead of doing x squared by itself, doing y squared?
Yeah, so it'd be just as equal, just as easy one way or the other.
Okay.
Yeah, be totally same. Yeah, either one. There's nothing preferable. Yeah, so then finish getting x alone. So what am I going to do? Divide through by the 4. Good. Divide through, divide through, divide through. X squared equals, what's that? 7, 18.5, I think.
Yeah. 37/2.
Yeah, so let's make it, let's go decimals. Those are easier, right? So there we go. I got the x squared alone. So everybody see what I did there? I just took that second equation, which looked a little easier than the first. And I got x squared alone. I got a decimal, but that'll be okay.
So can we just use decimals when it comes to things like that for most of these problems?
Yeah, I would. I think decimals are easier. Yeah, unless the decimal. The only time I would not use the decimal is if it goes forever. because then you're rounding. But any decimal that ends
Okay.
is better than a fraction, easier to use, you know. So yeah, so we get this. Now what are we going to do? That all came from the second equation, huh? So what does that mean I'm going to do with it now?
You're gonna plug it in first.
Plug it into the first, right? But it's going to plug in for the whole x squared this time. I'm not going to get x, I'm not going to root it, and get x, that'd be messy. Just take it as it is. Take it just as it is. And plug it in for x squared in the first equation. In fact, maybe it'd be best to bring that equation down. It's just getting messy here. Maybe I should do that. Let's do that. Wasn't that the first equation? 9 squared minus 1, yeah. So I'm just going to bring that first equation down here. And then I'm going to grab that whole x squared and plug it in right there. So can you take it from there? So plug that whole thing in. Let me let you. Okay, so we plug it in.
That's not right.
I should have done it the other way. And it's gonna be 4 solutions.
Equals 0.
Yes.
Okay. Yeah.
Equals 0.
Yeah.
So notice how,
Subtract.
first off, we're plugging in for x squared, not x, huh? So I don't have to square it again. You with me?
It's okay.
So I'm putting in 18.5 minus y squared, like that,
Distribute.
minus 5y squared plus 5 is everybody good? I don't have to do another square here, do I? Because that, you think, well, it's x squared, but that whole x squared is that, right? I'm replacing the x and the 2, the whole thing. The whole x squared is that 18.5 minus y squared. So it's good, just like that, right? No need to put another square. And now we distribute.
Yep.
Boom. And boom. What's 9 times that? 90, 162 and 166.5?
Yeah.
166.5 minus, oops, my pen's being crazy. 166.5 minus 9y squared. And then the other stuff, the minus 5y squared plus 5 is 0. And then we combine like terms. And so this will be minus 9y squared and minus 5 is minus 14y squared. And then the 166.5 plus 5 is plus 171.5. Yeah. We good to there? So now, if I bring it up here. Yeah, so now we're looking at this, huh? We're saying, let me bring it up. Like that. Okay, so bring it up here. So minus 14 y squared plus 171.5 equals 0. Yeah, when you see this and you see y squared and then just numbers, I remember back here when I gave you the basic game plan for this whole section, I said, where's it? There. I said when you see y squared and no y to the first, just y squared and numbers, no y, no regular y, that you just get that thing alone and root it. You don't have to do the whole zero factor in that case. If you just got y squared and numbers, no y to the first, just get it alone and root it, huh? So that'll be easier. So right here, I just get it alone. So I'm just going to jump that 171.5 to the other side, and I get minus 14y squared is minus 171.5, and then divide by the negative 14. And so y, what is it? What, 12?
12.25.
12.25, positive, right? Two negatives. And then put a root on it, huh? So root, well, what do you do when you put a root on? Remember my dorky saying up and down the ladder. So y equals
3
plus or minus,
3.5.
what is it?
3.5.
3.5?
Mm-hmm. Or 7 times.
Oh, okay. 3 point, come on, 3.5. So plus or minus 3.5. So we got our two answers for y. Now you plug back and get your two answers for x.
Y squared is 7.
Oh.
That'd be 2 times y would be 7. Y squared is going to be 12.25. We just had it.
Right. Oh, yeah.
So we're going to plug it back in. Basically, do you realize that there's no difference between the plus or the minus when you plug in? You don't have to separate them on this because everything's a square. There's no difference between plus and minus. Save some time. Does everybody see that? On problems 1 through 4, I had to worry about whether I was plugging in plus or minus because there was always a first power, right? Look back at this problem. See, when I got my x, I was plugging into that, which was a first power equation. So it mattered plus or minus. Well, I guess I didn't even have minus on that one. But here, I'm going to take plus or minus 3.5. And where am I going to plug in? Well, I want to get x. So it'd be nice to plug in where x is almost alone, right here. Right? But don't separate the plus and the minus because you're just going to plug into y squared anyway. Plus 3.5 or minus 3.5 squared is the same thing, huh? It doesn't matter. Does everybody see that? Save some time for yourself.
And if you already have like y squared, like
Yeah.
1, 2.
If we had a regular y to the first power, then I'd have to worry about plus and minus would be different, right? So I'll go to a fresh screen and go, okay, so y is plus or minus 3.5. Now I want x, so I'm going to plug into this guy here where x is almost alone. It's x squared. X squared is, what is it? 18.5 minus y squared. Minus y squared. And I'm going to plug in plus or minus 3.5. It makes no difference. So x squared is 18.5 minus, and I'll just write plus or minus. I don't know if you can read that. Plus or minus 3.5 squared. They're going to be the same thing, huh? There's no difference. If there's only y squared, it makes no difference. So x squared. So whatever answer I get is for both these guys, isn't it? It's two options. So what am I going to get here? 18.5 minus, and that squared is 12.25. We had it a minute ago. And so x squared is,
6.25.
is that what it is?
Uh-huh.
6.25, and then we root it.
X equals
2. Root it, up and down the ladder though, don't forget the plus or minus. So x is plus or minus, 2.5. All right, that means both of these x answers came from both of these y answers. So that's 4 answers. Do you realize that? Because both of those y's lead to both of those x's. So then the answer to our problem is, oh, it's not going to let me write it. Come on. 2.5 for x, 3.5 for y. Both positive. The second one negative. The first one negative. Both negative. There we go. 4 answers. 2.5, 3.5, and all the sign options. Because both led to both. All right, that's been a lot of those. You good with all those? Those are long and tedious. Bunch of messy algebra. Number 9 and 10, I'm not gonna do them. 9 and 10 are graphing calculator. And they say so right on them. They say graphing calc. We've done them before. You let y1 be the left side, like we even did on the test we just took. y1 is the right side, and do second calc intersect.
I want to mention that change the equation so it's y equals the stuff.
Right, you gotta get y alone.
Yeah.
Right. Yeah, good. Thank you, Wendy. Yeah, so some of those you have to get y alone, I guess. I didn't notice that. Yeah, so 9 and 10, graphing calculator. And that's the section. I want to go on to chapter 12, if that's okay. We good there? Want me to show you? Yeah, so 10. So yeah, you'd have to get y alone. So that means you would take that x squared and jump it to the other side. So you'd have y cubed is 2 minus x squared. Like that. And then, because you can't type it into your calculator till y is alone, right? You have y1 equals and y2 equals. Got to have y alone. So how do I finish getting that? It's almost alone. I got to get rid of that third power. How do I get rid of that third power?
Times it by 1/3.
Yeah, remember how we learned in the last section of the course to get rid of a power, you do 1 over that power or the root. It's the same thing, yeah. So, yeah, so I will come in here and go 1/3 power, 1/3, and these cancel. So y is 2 minus x squared to the 1/3 power. So there's y alone. This one, so that's going to be y1. This one, you can see it, huh? y2 is going to be 7 over x cubed when you divide by x cubed. So there it is. There's y1 and y2. Put them in your calculator, graph it, find the intersection like we did before on that. So I'll leave that.